All right, the 3.1 to 3.4 quiz study guide. First question is application of the definition of derivative. And I broke it into pieces like this to ensure that you use the definition of derivative instead of some shortcut that we've learned in future lessons, 3.3 specifically. Given the function f of x equals 3x squared plus 2x plus 1, find and simplify f of x plus h. So f of x plus h is simply going to be f of x with all the x's changed to x plus h's. Make sure whatever happens to x plus h. So x is squared, now x plus h in parentheses is squared. 2 times x is 2 times x plus h plus 1. That gets me 3 times x squared plus 2xh plus h squared. Make sure you're squaring binomials properly. Square the first, double the product, square the second. Distributive property here is going to be plus 2x plus 2h, and then plus 1. And finally, if I distribute the 3 through, I'm going to get 3x squared plus 6xh plus 3h squared, and 3 times all three things. Power first, multiplication second. And then plus 2x plus 2h plus 1. So again, the distributive property is happening here on the linear term, and it's happening here on the quadratic term after we've squared the binomial. You can see that there's no like terms there. That's as simple as I can get it. So for part A, that's f of x plus h completely simplified. Part B asks to simplify f of x plus h minus f of x. Okay, so f of x is this expression. F of x plus h is the blue expression. If I'm doing f of x plus h, the blue, which is 3x squared plus 6xh plus 3h squared plus 2x plus 2h plus 1. And I'm subtracting from an f of x, so I'm subtracting this entire expression. So minus the first thing, minus the second thing, minus the last thing. They're all positive, so when I subtract, they all become negative. If they had been negative, when I subtract, they become positive. What should happen for f of x plus h blue minus f of x black is that every f of x term has its twin in here, and the f of x is being subtracted, so we get opposites. So 3x squared cancels 3x squared, positive 2x and negative 2x, positive 1, negative 1. That's not a coincidence, that's what should happen. So as far as part B is concerned, all I got to do is subtract f of x away, leaving me with what is left over, 6xh plus 3h squared plus 2h. That's the f of x plus h minus f of x completely simplified. Part C asks me to perform the limit. Okay, the top part of the limit here, what I have highlighted in blue here, is the answer to part B. We just figured out f of x plus h minus f of x completely simplified is what's circled here in blue. That's what the top of this limit is. So when I apply this limit rule, limit as h approaches 0, of over h, what goes on top is simply what we just got on part B. So 6xh plus 3h squared plus 2h. That was supposed to be blue. Picked the wrong color. All right. And what happens and what should happen with this technique, which we've always had happen so far when we did it, is h, everything contains the letter h, so we can reduce by an h. So 6xh divided by h is 6x. 3h squared divided by h is 3h. 2h divided by h is 2. h divided by h makes 1, so over 1, which I don't have to put the over 1. And once I get the h off the bottom, I can't put 0 in right now because it gets division by 0. But once that h gets off the bottom, now there's division by 1. That's legal. Let h equal 0. There's no h there, so I get a 6x. 3 times 0 is 0. That goes away. Plus 2. That's my derivative. Okay? Using techniques from chapter 3.3, the answer to this should be the derivative of that, because that's the definition of derivative that we just did. All right? Using technique from chapter 3.3, f prime of x would equal 3 times 2, which is 6, x to the first, plus 2. You can see that the derivative is correct. If you get the correct derivative, that means you did everything else right. But again, I'm looking for the simplified version of f of x plus h here. I'm looking for the simplified version of f of x plus h minus f of x here. And then finally the derivative for the final answer. That's how I'm expecting it to look on your paper when I go through and check all your work. Number 2. Now we're going to be using our techniques from chapter 3.3. f of x equals all that, find f prime of x. This is just a power function and a power function and a power and a constant. So f prime of x is just the power rule for each one. 2 times 5 is 10, x to the first power. 2 times x, so it's 1 times negative 2 is negative 2, x to the 0, which goes away. Derivative of a constant is 0. F prime of x is 10x minus 2. It will be just that easy. Number 3. Also just as easy once it looks like a power function. You can see this one does not start off in power function structure. But if I rewrite it, the square root of t is t to the 1/2 power. Keep in mind, going back to algebra, square root of t, if I put in my understood stuff, t is to the first power and the index is 2. And to make a fractional power, we take the power divided by the index. So if that said, for example, the 7th root of t to the 8th power, that'd be t to the 8/7 power. So you want to create, from a radical structure, you want to create a fractional power structure. It's not necessarily going to be square roots on the test. So that piece there simplifies, or it changes to 2t to the 1/2. Now it has that power structure. T to a power, so now we can use the power rule. I've got minus 2 over t to the square root of t. That's minus 2 over t to the 1/2 power. Okay? Now that's a power structure, but it's on the bottom, so I can't use the power rule yet. At this point I have to use the quotient rule. But if we remember our laws of exponents from Algebra 1, we know that if I move the t to the 1/2 up, it changes the sign of the power, so I can move it up, it's t to the negative 1/2 power. Now I've got a power structure for each thing. Something times t to a power minus something times t to a power. Now the power rule can be used. At no point in time have I yet done calculus. I've not done a derivative yet. F of t equals, f of t still equals, f of t still equals. I'm performing some algebra to make the calculus easier. I'm about to apply the power rule of calculus. Now I'm going to write a derivative. So f prime of t equals 1/2 times 2 is 1. Subtract 1 from 1/2, I get negative 1/2. Negative 1/2 times negative 2 is positive 1. Subtract 1 from negative 1/2, I get negative 3/2. Be very careful that we're subtracting 1 every time. In fraction world, we got to get common denominator. And if you have a negative to start off with and you subtract, it's actually going to add the numbers to get your number out. The ones are not required. So if you just put t to the negative 1/2 and t to the negative 3/2, that'd be fine. It does have to be a plus sign between those also. Number 4, g of x equals this. Now, the way it's structured, I could use the product rule. Okay, 1d2 plus 2d1, it would work. All right, but again, if I perform some algebra first before I do the calculus, it makes life easier. The algebra I would perform here is I would take 3x squared times everything, then I would take plus 5 times everything. Then add like terms together. Do a little bit of polynomial multiplication out of this thing. So I'm going to say g of x equals, again I'm doing algebra right now, so I'm not going to write g prime yet. If I do my 3x squared first, 3x squared times 2x squared is 6x to the 4th. 3x squared times negative 3x is negative 9x cubed. 3x squared times 1 is 3x squared. 5 times 2x squared is plus 10x squared. 5 times negative 3x is negative 15x. 5 times 1 is plus 5. That gives me a simplified version of g of x as this power function g of x equals 6x to the 4th minus 9x cubed plus 13x squared minus 15x plus 5. And now it's just a simple polynomial structure. X is raised to powers, power rule for each object. So g prime of x, 4 times 6 is 24, reduce the power by 1. Negative 9 times 3 is negative 27, reduce the power by 1. 2 times 13 is positive 26, reduce the power by 1. 1 times negative 15 is negative 15, x to 0 goes away. Derivative of constant is 0. G prime of x equals that expression. That is the way I would do that problem. Again, 1d2 plus 2d1, then you still have to do a distributive property. You still have to add like terms. It's a lot easier to do it right off the bat, get a simpler version, and then do the power rule. Number 5. Once again, The structure here requires the quotient rule to happen, but if we use a little bit of algebra, we can then apply the the power rule. What I've got going on here is I got 4x squared plus 8x plus 6 all being divided by the square root of x, which is x to the 1/2 power. Again, it might not be a square root on the test, it might be a cube or a fourth or a fifth root. Alright? It'll be some radical x changed to a fractional power. We have three objects on top, 4x squared plus 8x plus 6, all being divided by x to the 1/2 power. I can do those individually. So if I do 4x to the second divided by x to the 1/2, the rule says I'm supposed to subtract powers. If I'm taking the top power 2 minus the bottom power 1/2, that equals 3/2, since 2 is equal to 4/2. So 4x to the 3/2 is equivalent to this over this. Similarly, this is 8x to the first divided by x to the 1/2. 1 minus the 1/2 equals 1/2, so I'm going to get 8x to the 1/2 power. And finally, the last one, there is no x here, but if I move the x to the 1/2 up, it's just going to become 6x to the negative 1/2. Again, x to the 1/2 on the bottom is the same as x to the negative 1/2 on top. And since I got multiple pieces over 1, I'm allowed to do each one individually like that to create this power structure. And if y equals a power structure, then y prime is just found by doing the power rule. 3/2 times 4 is equal to 6. 3/2 minus 1 is 1/2. 1/2 times 8 is positive 4. 1/2 minus 1 is negative 1/2. Negative 1/2, let the x off there, don't leave the x's off. So 1/2 times 8 is 4x, and then 1/2 minus 1 is negative 1/2. Negative 1/2 times 6 is negative 3. Negative 1/2 minus 1 is negative 3/2. And that is my first derivative. I'm fine with y prime as a notation for that. Number 6. This time, look at the difference in the two problems. This is over one thing, this is over a bunch of things. Okay? This is one where I can't split them apart like that. I could put 2t over all this stuff minus 5 over all that stuff, but that doesn't create a situation where it's simplifiable like these were. So I can't make a power rule out of, or a product, power rule out of that. I've got to do that as a quotient. So, once I see it's an unsimplifiable quotient, the quotient rule is required. The quotient rule is and always will be low D high, so let's use colors. Low is going to be red and high is going to be black. So if I do low D high, that means I take the bottom as is, 2t squared plus 6t minus 5. D high means derivative of top, derivative of 2t minus 5 is just 2. Minus, it's always minus. Then high D low, take the top as is. D low is derivative of the bottom, 2t plus 6, over the square of what's below. So whatever the bottom is squared. So in this case, t squared plus 6t minus 5 squared. Okay. What's left to do? And that's y prime. Okay. I performed a calculus task, the quotient rule, so I go from y to y prime using good notation in my work. This is kind of what the structure is going to look like when you have a polynomial quotient. You're going to get some sort of distributive property minus another distributive property, usually. The one place that people tend to mess up is this second one. It's minus that whole thing. So first off, you want to figure out what that whole thing is. So I'm going to FOIL this. 2t times 2t is 4t squared. Outside product and inside product, positive 12t minus 10t is positive 2t. And then last times last, negative 5 times 6 is negative 30. This stuff multiplies to that trinomial. Scratch sheet of paper if you have to, but get a trinomial there. Then the minus sign distributes through the product. Make sure it happens in that order. Right here, I got a positive 2 times a bunch of stuff here. That's just basic distributive property. So on top, I'm getting, for this part, 2 times t squared, 2 times 6t, 2 times negative 5. For this part, minus 4t squared, minus 2t, and minus 30, so plus 30. On the bottom, I'm just going to continue to get t squared plus 6t minus 5, the quantity squared. Leave the bottom just looking like that every time. Okay? There's no need to make the bottom more complicated than that. So the final step then is to combine like terms on top. Again, the bottom's going to stay t squared plus 6t minus 5, the quantity squared. The top, 2t squared minus 4t squared is negative 2t squared. 12t minus 2t is plus 10t. Negative 10 plus 30 is positive 20. Some of you might notice that every number on top divides by 2. There's no number on the bottom that divides by 2 outside that parenthesis, so I don't even look to try and reduce it. Made my quotient bar a little too big there. So that's the answer. Expect the structure on number 6 on the test to be similar. A trinomial and a binomial might be, maybe the quadratic will be on top, the binomial will be on the bottom, whatever, but it'll have those two types of functions. This type of math will be involved, so be careful that you do it properly. Most people, when they mess up, it's right here. They multiply this out, they just do minus the first thing, they don't put the parentheses around that product. So be careful that doesn't happen to you when you take the test. Number 7. Find the equation of the line tangent to the curve y equals 2x plus 4 square root of x at the point 1, 6. So, find the equation of the line means find the slope, find the y-intercept. As we've already discussed in class, the slope formula for any equation is its first derivative. This function y equals 2x plus 4 square root of x is a function that has a slope formula. In this case, I would rewrite the function as y equals 2x plus 4x to the half. I'd create that power structure we've done on all those other problems, since that's so easy to do. And then I would do y prime is equal to 2 plus 2x to the negative half power. And I might even go one step further and write it like that. Write it in a form that's a little bit easier for me to deal with. And notice I changed y prime into m just to really reinforce for myself that that's the slope formula for this function. So the slope of this function is 2 plus 2 over the square root of x. Unlike the slope of a line, which is constant, this is a variable slope, so depending on x, it's going to be different. The point of interest here, the point of tangency is 1, 6. That's x equals 1, y equals 6 is our point of tangency. So to find the slope at that point, I'm just going to change the x into a 1. So I get 2 plus 2 over the square root of 1. That's just 2 plus 2, which is 4. Once I know the slope of the tangent line, and I know the point of tangency, which is a point on the tangent line, I go to basic algebra, y equals mx plus b. Replace the point x and y with the slope, and also the slope into this to figure out what b is. So y is 6, m is 4, x is 1, b we don't know. 6 equals 4 plus b, so therefore b would have to equal 2. Slope 4, y-intercept 2, y equals 4x plus 2 is the equation of the tangent line. Anytime you want to verify a tangent line, it's real simple. Graph the equation. The original equation was 2x plus 4 square root of x. Our answer, y equals 4x plus 2. I want to make sure my point shows up, so I'm going to set a window here. X goes, let's go from -1 to 3. And let's go x scale of 1. And then y, let's go from 0 up to 12 maybe. And 1 scale for that also, a graph. So there's my 2x plus 4 square root of x. And there's my tangent line, which looks really tangent. So that's what it should look like. If it doesn't look tangent, then that probably means you're wrong, so maybe check your work. I wouldn't even know where mess-ups would happen on this. Maybe 1/2 minus 1 is negative. I don't know, something like that might happen. I don't know. But just be careful. Maybe you think the square root of 1 is a half. Whatever. Whatever causes you to get a wrong answer, just know that if it doesn't look tangent on the graph, then it probably isn't right. So go back to the drawing board. Number 8, find the equation of the line normal. Normal is perpendicular to the curve. All right, so the easiest way to do this is to find the slope of the tangent line and then make it perpendicular. So once again, my slope formula, y prime is going to equal 0 minus 4x. So the slope of this line, the slope of the tangent line to this curve is negative 4x. My point is x equals 2, y equals negative 5. And that's what the ordered pair means. So the slope of the tangent line is going to be negative 4 times 2, which is negative 8. Which means the normal line, which is perpendicular slope, is going to be positive 1/8. Perpendicular, change the sign, flip the fraction. 8 over 1 flips to 1/8, negative changes to positive. Both things have to occur to create the perpendicular slope. Same as the last problem. Once you know the slope and the point of normalcy, also the point of tangency, they're the same. Once you know a point and the slope, y equals mx plus b is our structure, because we're looking for the equation of a line. Y is negative 5, m is 1/8, x equals 2. In this case, 1/8 times 2 is 1/4. I've always recommended this technique when we're dealing with fractions. 1/8 times 2, 1/4. Always have the reduced fraction if it's a fraction. Common denominator of 4, so I need this to be over 4, so negative 20 over 4 is equivalent to negative 5, but it has the right denominator. Move the 1/4 over, I get negative 21/4 equals b. Slope of 1/8, y-intercept of negative 21/4. Equation of the normal line, y equals 1/8 x minus 21/4. This is also checkable with your calculator. Y equals 3 minus 2x squared. And my equation of my normal line is 1/8 x minus 21/4. That's x divided by 8 minus 21 over 4. Okay, on this one though, I want to be a little bit more careful as how I do it. I'm going to go to window, I'm going to set my x so that x is on there. So negative 1, let's go up to 5. Okay, so 2 is between negative 1 and 5. Now on the y, I don't want to set the y because I want to make sure it looks perpendicular. So I'm going to go to my zoom, and I'm going to choose zoom square. We have a rectangular screen, we want it to look square so we can see better that it intersects properly. Where's my other line at? Oh, I know what's wrong. It's modifying the x's, not the y's. Let's go from y min, let's go negative 10 up to 0. And now let's try zoom squaring it again. Hopefully we'll get the x's happening. Zoom square. My point of normalcy is right here. It should look like a right angle happening. We can't assume right angles, but it should look really right angle-ish. Okay? If it does, that means you probably did everything correctly. Ones I've seen wrong, they're going like this. I mean, they're like way off. Let me just bring this over here just to give you an idea. Wrong answers I've seen on a problem like this. If I were to graph it, it would look like this. That's obviously not a right angle. It might look like even that, which, I mean, hopefully people can see that's an obtuse angle. So the wrong answers are very obviously wrong. So if you wanted to check using a calculator with that zoom square function, that would be helpful. If you don't do the zoom square, it might look like one of these and still be square, so be careful with that. Let me just give you an idea of that real quick. Let's go from, I don't know, negative 2 to 6. Okay. We already know it's normal because we did the zoom square thing. We get the stuff in wrong, and that doesn't look like a right angle, even though it really is. It has to do with the optical illusion created by having a rectangular screen trying to create a square look. So the zoom square creates that square look. It modifies numbers properly, so it looks correct for what it really truly is. Number 9, particle moves according to the function f of t equals t squared minus 4t plus 12. Where t is measured in seconds and f of t is measured in feet. So f of t is where the thing's at, t is how long it took to get there. All right, so at 1 second it's at some point, at 2 seconds at some other point, and so on. Question A asks us to find the velocity at time t. As we've discussed in class, velocity of anything of a position function is just the derivative. So if the position function is this, the velocity is going to be the derivative, which is 2t minus 4. That's how you do part A. On the test, it'll be a position function similar to that. Velocity will be found similarly. Okay. Part B, when is the particle at rest? velocity equals 0. At rest means velocity equals 0. I have a velocity function. This expression 2t minus 4 represents the velocity of this particle at any given time t. So if I set that velocity equal to 0, I find out that at 2 seconds this thing's going to stop. Part A, velocity function. Part B, apply the velocity function to a velocity of 0 to find out when. And if it says when, it's looking for a time. What is t when v is equal to 0? Hey, part C. When is the particle moving to the right and to the left? And that's D also, C and D. We'll do those together. All right. This is the velocity of this particle. And we're going to assume that this starts at time equals 0. It doesn't specify that, but typically when we have particles moving, we start at time equals 0. So once I found out when it gets to rest, I'm going to start at 0 and go to 2. Then I'm going to go from 2 to infinity. There's no stopping point in this situation. And all I want to know is how fast it's going, okay, at each of these. I need to know which direction it's going. Right is a velocity that's positive, and left is velocity that is negative. So if I pick a test point in that interval, t equals 1, t equals 3, we already know it stops at 2, so at 2 it's 0. It has no sign, positive or negative. But from 0 to 2 it's going to be going some direction. From 2 to infinity it's going to be going to another direction. This is the only time it stops. So if the particle's moving along, if it stops, it has the ability to start going back the other way. If it doesn't stop, it can't go back the other way. So the only stopping point's at 2. So once 2 happens, it has to be going the same direction from that point forward. So v of 1, because again we're looking for velocity, going back to the velocity function, 2 times 1, 2, minus 4 is negative 2. So I get a negative velocity there. 3, 2 times 3 is 6, minus 4 is positive 2, I get a positive velocity there. So it's moving to the right from 2 to infinity. It's moving left from 0 to 2. I'm expecting proper interval notation on these answers. There is a parentheses at 2 because it stopped at 2. It's not moving right or left, it stopped. So that's why we have no bracket at 2. It starts off at 0, and notice 0 minus 4 is negative 4. So its beginning speed is already negative at 0 seconds. So it is moving left at 0 seconds, so that's why we have a bracket on that. We never put a bracket on infinity. Final question E, how much distance has the particle moved during the first 9 seconds? Now this is an easy question to answer. All we have to know is when did we start, when did the particle stop moving, and when do we end? Okay, so we're starting at 0 seconds. It stopped at 2 seconds, and it's ending at 9 seconds. That's the information we need to know. When did it start? When does the particle stop in the time interval we care about? And when does the particle end? Or when does the problem end? So it says first 9 seconds, so that's end 9. We always start at 0. The question says how much distance has the particle traveled or moved? Okay, distance is the function having to do with position. So we're going back to the position function here, t squared minus 4t plus 12. So what I want to find out here is f of 0, where was it when we started? F of 2, where was it when it stopped moving? And f of 9, where was it at the end? Okay, f of 0 means 0 minus 0 plus 12. So its initial spot is 12 feet. F of 2, 4 minus 8 is negative 4 plus 12 is 8. After 2 seconds, it's moving left, right? So the particle is at 12 feet, it moves left. And at 2 seconds, it's at a position of 8 feet. So 0 feet's over there somewhere. And then at f of 9, 81 minus 36 is 45 plus 12 is 57. At 9 seconds, it's way down there at 57 feet. So it's at 12 feet to start off with, moves back 4 feet, then it goes all the way up to 57 feet. Question says, how far did it move? Okay? From here to here is displacement. From here to here, which is 4 feet, and from here to here, which is 49 feet, gets me a total distance moved of 53 feet. Okay? If I want to know displacement, how far is it from its original position? It started at 12, ended up at 57, that's 45 feet. from its original position, but the particle moved 4 feet this way first, then it moved 4 feet back for a total of 8 feet before it moved to the other 45 all the way up to 57. So be careful that you find me how far it moved for each one. So 12 minus 8 is 4, 57 minus 8 is 49. Big minus small in each case to get a positive distance traveled for each leg of its trip to get the total distance traveled. Number 10. Ball's thrown vertically upward with velocity 128 feet per second. Then its height after t seconds is s equals 128t minus 16t squared. Okay. Question A, what is the maximum height reached by the ball? Okay. What we have to know is that when a ball's thrown up in the air, it's going to go up in the air until it stops, at which point it's going to start going down. The point at where it stops is its highest point. So the maximum height occurs when velocity is 0. Nothing in this problem tells me when the velocity is 0. I know initially it's 128 feet per second. Gravity is slowing it down, so eventually it has to stop because that's how gravity works. But I don't know when it hits the velocity of 0. So to do part A, I want to find the velocity function. This is position, the height, so height being position of the ball after a certain amount of time. So anytime you have a height versus position, or sorry, height versus time, position versus time function, the derivative of the position variable is going to equal the velocity function. So 128 minus 32t is the velocity of this ball. If I set that equal to 0, I determine that at 4 seconds the ball should stop. Okay, once I know the ball stopped at 4 seconds, the question says what's the maximum height? Height is s. And s is this formula here. So once I know what t equals when the ball stops, I simply substitute t in place of those t's up there. The height that is reached by the ball after 4 seconds is going to be 128 times 4 minus 16 times 4 squared. Of course, 4 squared being 16. 128 times 4 is 512. 16 times 16 is 256. Subtract and we get 256 feet is the maximum height reached by the ball. Question B. What is the velocity of the ball? So they're asking me for velocity. In order to find velocity, I need to use the velocity function. If I know what t equals, I know what the velocity is at any given time t. I want to know the velocity when the ball is 240 feet above and below, or above the ground on its way up and down. Okay? I don't know when the ball is 240 feet above the ground because it doesn't tell me. Oh, by the way, at t equals this time, the ball is exactly 240 feet above the ground. But it does tell me where the ball is at any given time t. T is equal to any number here. Position is s. So I'm going to let this equal s and then solve for t. So I'm going to get 240 equals 128t minus 16t squared. I noticed that 16 divides all three numbers, so I would probably do that. 240 divided by 16 is 15. 128 divided by 16 is 8. 16 divided by 16 is 1. If you don't notice that, it's still workable, but it just makes it easier to do that. I move the t squared and the 8t over to the left. I like my quadratic term positive if I'm going to solve a quadratic equation. T squared minus 8t plus 15 is equal to 0. This one happens to be factorable, t minus 3 times t minus 5. If you can't factor it, or it's not factorable, then quadratic formula will be legal at this point also. Negative b plus or minus square root of b squared minus 4ac over 2a. Again, factorable is easier if you notice it. So at t equals 3 and 5 seconds, it's going to be at 240 feet. Now, me knowing physics the way I do, and hopefully you understand physics at least this much, the ball goes up until it stops. It stops at 4 seconds, right? So if it stops at 4 seconds, 3 seconds is over here, and as it goes downward, 5 seconds is over here. So if it's asking for the way up, that would be the 3 seconds. On the way down, that's the 5 seconds. All right, hopefully that's obvious to everybody. So to do the 240 feet above the ground on its way up, I'm going to figure out what v of 3 is equal to. That's just going to be 128 minus 32 times 3, because I'm using the velocity function here, changing t into a 3. So v of 3 ends up being 128 minus 96. So it's 32 feet per second. I know it's feet per second because that's the units I'm given. Height after t seconds, 128 feet per second is that. They don't specify that s is in feet, but that implies it. The other thing I need to know is its way down velocity. So velocity at 5 seconds is going to be 128 minus 32 times 5. That's 128 minus 160. That's negative 32 feet per second. So positive 32 feet per second going up, negative 32 feet per second going down. That is typical with projectile motion. If you're at the same height going up and going down, that the velocity should be the same but opposite. Going up is a positive velocity, going down is negative. So even if you didn't go through this thought process here, which one's up, which one's down, the positive velocity is the up one, the negative one's the down one, so you should know that. That is the entire quiz study guide. As with all these other quizzes, I expect it all to be done within one class period. Hopefully you solved it. About 4 or 5 of the first 6 questions were really fast. That should leave you enough time to go through some of these word problems correctly.